Hi everyone, I am Jian and my group members Ling Shyang, Wong Wong Yuen, Vanessa Clement, Chongchong and Siti Norhuda binti Abdullah. We are from group 3. We would like to share a topic about an excavation method, blasting. This is the content we would like to share: introduction, method, stage, and blasting and environment. So first, what is the excavation? The Department of Occupation Safety and Health defines the excavation work as the work that remove of earth, rocks, or other materials in connection with the construction or demolition works using tools, machinery, or explosive to form an open space, hole, or cavity. The excavation work includes any earthwork, trenching, coffin dam, caissons, well, shaft, tunnel, and underground working. The excavation of underground is divided into mechanical and non-mechanical. The mechanical type is the excavation work that uses machine to excavate. Usually, the TBM, tunnel boring machine, and root meter are used in this type, while the blasting is for non-mechanical type. The blasting is also known as drill and blast method because the drilling process is involved. As mentioned, it is a non-mechanical method. It is widely used in rock excavation technique because it can be used in all types of rocks. It has a lower initial cost compared with the mechanical method. The excavation rate of blasting is about 3 to 5 meters per day. And this is the ammonia nitrate fuel oil. Usually we call it as a NFO. NFO is the explosive product which commonly used for blasting due to the high stability and low cost. Blasting can use in all types of rocks. It has lower initial cost compared with the mechanical method. It requires the minimum cleanup work because it is less waste in material. However, the potential hazard is higher with the usage of the explosive involved. It can create the higher vibration level due to the explosion. The flying rock will be created. And compared with TBM, the blasting method has a lesser excavation rate, which TBM can up to 15 meters per day.
Hi everyone, my name is Jackson. Now I'm going to present about method of blasting. In this presentation, we are going to focus on control blasting method. Control blasting method is a blasting technique to reduce the amount of overbreak and fracturing of rock beyond the design boundary of excavation. Furthermore, it also controls the excessive fly rock and ground vibration during the blasting process. Compared to normal blasting, control blasting method reduce the perimeter cracking as well as increasing the stability of the opening. Several examples of control blasting method are line drilling, pre-splitting, smooth blasting, and cushion blasting. Line drilling as one of the control blasting method is used mostly in small blasting job with light load of explosive. Furthermore, line drilling involves the drilling process of a row of closely spaced holes which is approximately 2 to 4 diameter apart along the excavation line. In addition, line drilling provides a plane of weakness to which the primary blast can break, and to some extent it reflects the wave created by the explosion. as well as reducing the shattering and stressing in the finished work. The use of the line drilling is limited to jobs where even a light load of explosive in the perimeter hole would cause unacceptable damage. Line drilling provides a minimum disturbance to the surrounding environment, and it shows a good flexibility to allow a quick and effective move of the rock to place utilities, pipes, and water or sewer lines. Moving on to the next point, pre-splitting, sometimes called as pre-shearing, is similar to line drilling, except that the holes are drilled further apart and a very light load of explosive is used in the hole. Furthermore, pre-splitting induces a fractural plane along a required design profile, which isolates the rock to be blasted from the surrounding rock mass. The holes are generally fired instantaneously in advance of any blasting in the adjacent rock. Pre-splitting in the rock forms a discontinuous zone that minimizes or eliminates overbreak from the subsequent primary blast and produces a smooth finished rock wall. Last but not least, pre-splitting is also used to reduce ground vibration in some critical cases.
The third method of control blasting is smooth blasting. Smooth blasting, also called contour blasting, is the most widely used method of controlling overbreak in underground openings such as drift and stopes. It is similar to pre-splitting in that it involves a row of holes at the perimeter of the excavation that is more lightly loaded and more closely spaced than the other holes in the blast round. Unlike pre-splitting, the smooth blast holes are fired after the main blast. The holes are drilled along the excavation limits, lightly loaded with well-distributed charges, and fired at the end of the round. The holes for smooth blasting should be fired instantaneously or with minimum delay to achieve a shearing action and smooth walls with minimum overbreak. Smooth blasting reduces overbreak and reduces the need for ground support, which usually outweigh the cost of additional perimeter holes. As a first approximation, the burden on the perimeter holes should be approximately 1.5 times the spacing as shown in Figure 4, the typical smooth blasting pattern. The fourth method of control blasting is known as cushion blasting. Cushion blasting is a surface blasting equivalent to smooth blasting. It involves a row of closely spaced, lightly loaded holes at the perimeter of excavation. In cushion blasting, the charged holes are further decoupled by reducing the diameter or using stemming material of crushed stone or sand to provide a crushing effect. This will cushion the shocks from the finished wall as the holes are detonated and minimize the stresses and fractures in the finished wall.
There are 6 stages of blasting: site inspection and survey, blast design, pre-blast meeting, trial blast, blasting, blasting meeting and review. The first stage is site inspection and survey. This activity is prior to the start of the work. The engineer and engineering geologist should be involved. The purpose is to find out the best excavation method. This activity is subject to several laws and acts in Malaysia. For example, Explosive Act 1957, Environmental Quality Act. Excavation method depends on 5 factors: environmental constraint, also known as safety, specification of work to be carried out, cost, rules and regulations, excavation assessment. The second stage is blast design. Blast design should be completed 10 working days before a pre-blast meeting. The contractor's project blaster should submit the design to the engineer for approval. The engineer should provide a copy of the design to the regional geotechnical engineer for evaluation. The blast design is based on the current rock formation and overburden conditions. All necessary safety procedures should be considered. There are 5 blasting design factors, which are borehole diameter, burden, spacing, stemming, delay firing system. The third stage is pre-blast meeting. The blast strategy and other relevant information will be discussed in this meeting. The engineer, the contractor, the project blaster, a geotechnical engineering geologist, and other relevant parties will attend this meeting. The purpose of this meeting is to get final approval to blast. The fourth stage is trial blast. Trial blast is a test blast before normal blast. The purpose is to confirm the basic assumptions and give data required for the final blast design. The engineering geologist will assess the test blast to see whether any changes to the stock slope design or blasting activities are required.
Hello everyone, my name is Ling. So now I'm going to talk about the blasting. Blasting will take place in compliance with Malaysian laws and regulations. Before work begins, the appropriate permissions will be secured from the appropriate authorities. Before blasting, a notice will be sent to the related authorities and an announcement will be made to clear the quarry site. Storage of the explosive will be required to get the approval from the government. And all the blasting activities will be closely monitored by the engineer and safety officers. Only qualified individuals with expertise and understanding in the safe handling of explosive will be assigned to be the supervisor of the blasting activities in each blasting location. And the transport of the explosive will be supervised by the police. There will be 4 main important procedures in blasting, which are drilling, charging and blasting, dislodging and dumping, and securing. The first procedure will be drilling. Drilling operations are carried out using the crawler drill machine either in pneumatic or hydraulic way. The drilling rig bores the drilling holes defined in advance in a blasting plan in the tunnel first front wall before blasting begins. The more solid the rock is, the more explosives are used. And there will be 4 main factors that will be impacting the pattern of the rock drilling, including the geology of the rock, the hardness of the rock, the hole size, and the bench height. The second part will be the charging and blasting procedure. The drill holes have now filled with explosive, the detonators have been affixed to the explosive device, and the individual explosive device has been linked. The holes are blasted one by one, starting in the middle and working outward. The charge estimation is constantly influenced by the drilling pattern and the blast design, as well as the knowledge and experience dealing with explosive and the characteristics of the rock. The main blasting agent will be ammonium nitrate with the mixture of fuel oil, or we can call it as ANFO. After the blasting, dislodging and dumping will be carried out. Dislodging means the removal of the loose fragments of rock that were not entirely free from the rock during the blasting process. This working phase is finished by a powerful tunnel excavator. The blast debris are all hauled out of the tunnel once the loose bits of rock have been loosened from the working phase. The material is either placed onto dump trucks with the wheel loaders and carried out from the tunnel and to the outside landfill, or it is conveyed and on the conveyor belts from the area of excavation to the landfill. The last part will be securing. Securing is used to allow for a cavity-free connection of the securing device to the rod, and it is very dependent to the type of the rod. There are a range of securing measures such as wire mesh, tunnel arches, stacks, or so-called bolts that can be driven into the rod can be used. Rod bolting is the most common method for the stabilization of the rod face. Under the most difficult ground condition, steel arches may be required to support the tunnel's wall and roof. In other cases, a steel mesh may be attached to the walls and roof to keep the loose item from falling onto the employees below. After blasting have been done, blasting meeting and review will be carried out. Meetings may be convened during any time during the project at the engineer's request to assess the status of the blasting operation, considering the revisions to the practices and techniques of the documented plan, and discussing the difficulties with impending blast. If a blast causes injury, property damage, adverse traffic effects, or any gases to be spread or accumulated in a potentially hazardous way, all the blasting operations must be halted by the engineer for a review for the process. The engineer will undertake the review in collaboration with the engineer geologist to confirm the proper procedures and practices will be followed and to assess whether the approved process need to be amended.
Hi everyone, my name is Vanessa Clement. Next, I will be talking about the effect of blasting on environment. During the blasting activities, there is only 20 to 30% of the user's energy is served for the rock fragmentings and displacings, while the rest is actually wasted in the form of ground vibrations, air blasts, noise, and fly rocks. So blasting operations able to cause several adverse environmental effects, which included the ground vibrations, air blasts, fly rock, generations of fine dust and noises, as well as the chemical contaminations of soil and water. So the first effect is ground vibration. So ground vibration is actually similar to the seismic event, which causes the ground to shake. So ground vibrations is transmitted from the blast sites and travel at different rates through soil rocks and water until its energy of the vibration is dissipated. So basically, ground vibrations will move faster and at a higher frequencies in the rock than in the soil. While for the vibration effect, it is actually dependent on the distance of sensitive area, such as the house that's shown in the figure, and also the rock characteristic. The blast-induced ground vibrations causes detrimental effect on the structure in the nearby environment, such as the building, dam, road, and railway, as well as the natural slope. Next is the air blast. So air blast is the air wave generated by the blasting operations. For the effect of the air wave, it is actually unusual for the air wave from the blasting operations to reach a potentially damaging level for the residents, but if they really do, the damage is usually in the form of the broken window. But even in the operations where there is no damaging potentials, the airwaves are still able to generate sound between the frequency range of 20 to 20,000 Hz, which can be heard by the residents of an area. So there are two possible reasons or sources of air blast occur, which include poorly steamed hole and also the blown out chutes resulting from the poor design patterns. Fly rocks are the rock ejected from the blast surface at a very high speed, which it may causes injury and damages to the surrounding environment, peoples, buildings, and vehicles. So there are a few probable reasons for the fly rock to occur, which could be insufficient overburdens, inadequate steamings, incorrect spacing, and also the overcharging with explosives. However, with a good supervision and good blasting design technique, the chances of the fly rocks can actually be minimized. Next is the effect in terms of dust and noise. The environmental effect of noise and dust is varied depending on the size and locations of the blast, as well as the atmospheric conditions such as the wind and the humidity. So the consequences of dust or the particulate matters that suspended in air may affect the surrounding air qualities, create an uncomfortable environment for the public, which includes irritations of eyes, ears, nose, throats, and skins of humans. Besides that, the dust depositions on the vegetations also able to affect the photosynthesis process and affect the growth of the vegetations. While for the noise induced by the blasting, it can diminish the human's quality of life by causing the nuisance, sleep disturbance, as well as affect the wildlife and domesticated animals. Lastly is the environmental effect in terms of the chemical contaminations of soil and water. If the commercial explosives are spilled on the ground or left undetonated at the blast sites, ammonium and nitrate can actually reach into the ground and surface water. Moreover, the Department of Environmental Protection have also warned that the perchlorate, which is present in some blasting agents and explosives, has actually contaminated a number of drinking water supplies near the blasting activities.
Hi, I'm Siti Norhuda. In this part, I'm going to explain about the best management practices or BMP for blasting activities to avoid environmental contamination. The best management practices or BMPs is practically a guideline to include preparing, reviewing, and following an approved blasting plan, proper drilling, explosive handling, and loading procedures, observing the entire blasting procedure, evaluating blasting performance, and handling and storage of the blasted rock. Here are the best management practices as packs that must be focused in line with the environmental management. This BMPs is established by the states of New Hampshire and the Institute of Makers of Explosive in the United States, published by the statewide publications in December 2016. There are 6 main criteria, which is the first one is must not use the perchlorate, explosive, or initiators. Second, it must apply comprehensive drilling and loading practices. The third one, it must focus on the explosive selections as well as the ammonium nitrate and fuel oil OA and FO used. And the fifth one is the bulk emulsions and slurry or water jet explosive. And the last one is the mark pile management. Let's look into in details for each of the guidelines in the BMPs. The first one is no perchlorate explosive or initiators used by any projects. Perchlorate is basically a chemical that containing high density and high explosive energy, which by means it has high capability in explosion activity. It is also mostly used in difficult blasting applications, especially for wet, hot, or dense rock blasting applications, in missile and rocket propulsion system as the solid oxidants, and also in the fertilizers in industrial use. The contaminations of perchlorate will affect human health, especially in thyroid gland function, where is mistakenly taken up in place of iodide from the uptake of groundwater, which is contaminated for drinking purpose. Ammonium perchlorate is mostly found in the drinking water. The second one is to apply comprehensive drilling and loading practices. This is important as to minimize environmental effects due to drilling and loading activities, hence to prevent the release of contaminants to the environment. It includes the blast hole procedures, which is in terms of considerations of length and depth of voids, cavities, and fault zones, or other weak zones encountered as well as any groundwater conditions. It is also include the on-site management of it, explosive products, which must be used in the borehole, returned to the delivery vehicle, or placed in secure containers for off-site disposals. Next, it is also important in the water flowing conditions, which important to the selections of material used in the explosions. And the next one is the management of wastewater control for loading equipment. Third, we will look into the explosive selections. It needs to be focused as to reduce the potential for groundwater contaminations. The explosive products chosen must be appropriate enough for site conditions, safe blast executions, and have appropriate water resistance. All of this can minimize the potential for hazardous effect of the products upon groundwater. Next, the proper handling when using ammonium nitrate and fuel oil, or ANFO. The use of ANFO must be handled with proper procedure to reduce nitrate or other impacts, such as spills to surround conditions. It includes water resistant cleaning and waste management, especially when there is spills, which must be cleared properly and reused, or else taken off from the site in appropriate handling and disposals, blowback reductions, and deloading phonetically and blast hole proximity effects. Next one is the proper handling of bulk emulsions and slurry of water gel explosives. It is important as to reduce the potential for nitrate contaminations or other impacts. Spills of the products must be removed from the spillage area. Proper loading techniques, especially into wet blast holes. If groundwater condition is severe, packaged explosive is used instead of bulk products. The last one is the mud pile management. It is important as it can reduce the potential for contaminations in the air, surface, and groundwater by implementing 1. Remove the mud pile from the blast area as soon as reasonably possible. Next, to manage the interactions of blasted rock piles and storm water to prevent contaminations of water supply wells or surface water. That's all from us. Thank you.